So let's start. Good morning, everyone. My name is Ugo Simeoni. I'm Research and Innovation Manager at ETN. I would like to welcome you to the first episode of the Flexible Power Generation webinar series organized by the European Turbine Network in cooperation with the ETIPSNet, the European Technology and Innovation Platform, Smart Networks for Energy Transition, and 5 Horizon 2020 projects, namely the Flex and Confu, Pump Heat, High Flex Power, SCO2 Flex, and Turbo Reflex. I would like to welcome our speakers, Mr. Hans van Steen, Acting Director, Renewables, Research and Innovation, Energy Efficiency from the European Commission, Mr. Christer Björkqvist, Managing Director of ETN, Mr. Simon Balmer, Operations Director, Gas Turbine Fleet, Uniper, and Mr. Mauro Moretto, Vice President, Technology, Ansaldo Energia. Welcome and thank you for being here with us for the first episode of our Flexible Power Generation webinar series. This webinar series wants to be a journey with the policymakers, academia, industry representatives, and the general audience to discover the exciting research and innovation activities carried out in the last years to transform and make more flexible fossil fuel power plants. To do this, over 6 months, we will follow the path of 5 different projects funded under Horizon 2020 Research and Innovation Program. Those 5 different projects explore different ways to increase the flexibility. It could be through power to X to power solution using hydrogen and ammonia as energy vectors, like in the Flex and Confu and High Flex Power projects. We will tell the story of projects that want to improve operational flexibility with heat pumps, like in the pump heat, or by using supercritical CO2, like in the SO2 Flex projects, or by developing and optimizing turbine components for existing or new turbomachinery, like in the Turbo Reflex project. All these projects shows the investments that has been done in the sector and highlight the importance of developing solution for a deeper integration into an advanced energy system with the higher shares of renewable energies for both existing and new thermal power plants. In fact, as you know, wind and solar power are highly variable depending on factors such as the weather conditions and times of the day. Therefore, it is the duty of fossil fuel power plants to back them up, shifting their role from base load to fluctuating power sources to meet unpredictable and short notice demand peaks, and most of all, to avoid disruption in the electrical grid. But what are the key elements? One of these, as we said, is the flexibility. The other one, definitely this integration, has highlighted in the EU Energy System Integration Strategy released in July 2020. In the system integration strategy, in fact, the European Commission laid the foundation to shape a new and more efficient integrated energy system that can facilitate the energy flows between users and producers. This would result in a cleaner power system with a more direct electrification of end-user sectors, as well as the use of cleaner fuels for the hard-to-electrify sectors. In the scenario portrayed in this strategy, the share of electricity in the final energy consumption will grow from 23% to 30% by 2030 and up to 50% by 2050. This obviously poses challenges in terms of security of energy supplies, for which centralized power generation plays a major role. Moreover, the increasing global interest towards hydrogen as energy vectors open new opportunities for gas turbines, which have the potential of becoming a green technology and could play a primary role in decarbonizing the energy system in the long term. However, the regulatory framework does not always clarify the role of centralized power generation and fossil fuel power plants in the future energy scenario. Therefore, an open dialogue between regulators and the industry is needed to pave an economically and technically feasible way to achieve carbon neutrality by 2050. This, of course, without compromising the stability of the grid and of the market. Now, without further ado, I would like to leave the floor to our first speaker, Mr. Hans van Steen, Acting Director, Renewables, Research and Innovation, Energy Efficiency from the European Commission. Mr. van Steen joined the European Commission in 1989, where he has taken over several assignments in the field of energy and transport. Mr. van Steen, could you maybe tell us more about the European Commission's climate ambitions and the role you foresee for centralized power generation?
Yes, good afternoon, everyone. And thank you very much for inviting the Commission to this webinar today and this important series of webinars that you are planning here. I'm really pleased to address you all and try and speak a little bit about the way forward that we see it from the Commission in terms of our 2030 and 2050 climate and energy objectives, and also the role of flexible power generation in future energy scenarios. Could I begin perhaps by just thanking ETN Global, but also ETIP SNET for having organized this webinar. We think it is really very, very useful. As you know, and I'm sure many of you heard it, the State of the European Union speech by President Ursula von der Leyen in the middle of September confirmed very clearly the European Green Deal as, shall we say, the blueprint for the EU's transformation into the first climate neutral continent by 2050. As you know, this is not just about climate change, this is also actually a new European growth strategy. And I think what we know and what we see very, very clearly is that if we are to meet these very ambitious objectives, we need not to do things like we're doing them today. We need to do things much better, and we need to be accelerating our process of decarbonization in all sectors of society. But of course, energy, which is responsible for about 75% of all CO2 emissions, if you also include transport, is absolutely critically important. And it was on that basis that the Commission has now proposed to increase the 2030 target for emission reductions to at least 55%. You know, today we have a reduction commitment of 40%, which is notified under the Paris Agreement. We're now proposing to significantly increase that to 55%. And that was announced together with the State of the European Union speech. And the whole announcement came together with a very comprehensive impact assessment, which I would really strongly encourage you to look into. A lot of work, a lot of man hours from colleagues went into that document over the summer in particular. And it does contain a wealth of information. It shows very clearly that it is possible to move to 55%, both in terms of what our economy can manage, but also in terms of what industry can manage. And that is, of course, very important also in the context that we're discussing here today. We're now, in addition, of course, facing the global pandemic, and there we need to, of course, see all of this very much in connection with the recovery programs of the EU, the so-called Next Generation EU, where we have now announced or proposed, and it will soon hopefully be confirmed, that there will be about 750 billion euros available for recovery, some of it loans, some of it grants, and a very, very large chunk of that should be spent directly on European Green Deal objectives through the so-called climate mainstreaming. We in Energy have already prepared for this for some time. We have already quite a lot of legislation in place, but we also see a need to do much more. And I think that was very clearly expressed in the strategy for energy system integration that came out in July, where we, for the first time, looked at the energy sector in a very holistic way, seeing how can we try and exploit the synergies between different parts of the economy when it comes to energy, sectors of the economy which today are looked at separately, industry, transport, buildings, even agriculture, need to be much more holistically assessed in terms of moving towards climate neutrality in a cost-efficient and cost-optimal way. This so-called energy system integration strategy was or is based on three pillars. First of all, we need to continue our efforts on energy efficiency. We will, of course, see a continued electrification, and this electrification should be based on renewables. And overall, we need to see how we can use renewable and low carbon fuels, such as sustainable biogas, biomethane, hydrogen, and synthetic fuels, also in parts of the industry and economy which are so-called hard to abate sectors, where it is maybe difficult to use renewables in the shape of electricity as it is today. In this whole strategy, flexibility is a key word. I think flexibility of power generation, but flexibility of the system as a whole is really important. This is also true for turbine-based power generation, which indeed present characteristic that makes it a very good complement to variable renewable generation, quick ramp up and ramp down times, ability to run on low capacity factors, and so on and so forth. But also other types of flexible technologies, other technologies will have to be looked at, and we also need to look at the demand sector. We cannot just look at supply. Flexibility will indeed be a key word for the entire economy. In all of this, diversification should not be forgotten. That will be another key word. We need to use all the different types of renewables that we have available to us, and we probably also need to look at least in a bridging situation, how we can diversify further the fossil fuels type of energy sources that we're using today. What we will see in the future is clearly a mix of centralized and decentralized power. We will see centralized generation, for example, in the shape of large renewables, but also nuclear, and that will, of course, continue. And that will be transmitted maybe over long distances also as we see it today. But at the same time, we will see a lot of decentralized renewables, what we call distributed renewables in particular, smaller wind farms, for example, or solar PV to a very large extent. And all of this, we will see an increasing number of small distributed loads at distribution level, which can to some extent be met effectively by distributed generation. Again, here, I think the key word is really diversification. You mentioned in the beginning a number of Horizon activities that have already supported this quite clearly. Already on the Horizon 2020, there were two calls, one in 2017 and one in 2019, which was addressing exactly that. And you mentioned some of the projects that are being supported through that call, and I think we will hear from many of them later today, and we'll look very much forward to that. I think it's total funding of something like 39 million euros, so it's quite a significant effort that goes into this. And it shows that this is something that we believe is really important from the Commission side. Of course, when we're looking at, for example, gas turbines, these are not carbon neutral, and we know that carbon neutrality is what we are ultimately aiming for. And in any event, these turbines are only as clean as the fuel that you put into them, unless you're able to capture the CO2 in CCS technologies or in other ways. We also support RNI into different kinds of turbines using example, industrial waste heat and recovering that and reusing it. And excess heat, you will have noticed it was a big topic of the energy system integration. And that, of course, can be used in many different ways, and we need to find out and exploit the best way of doing that. You mentioned some of the technologies that we are looking at, innovative thermodynamic cycles, organic fluids, and so on. And all of this will need to come together in order to make its contribution towards the decarbonization process more generally. We will continue to do that. There's a call which has just been closed under Horizon 2020, probably one of the very last. And of course, as you know, we are in Horizon Europe now working on the work program for that program. And again, this is an area where we will continue to devote resources under that program. I will leave it there. Thank you very much for listening to me, and I'm looking forward to hearing the contributions of the other panelists as well. Thank you very much.
Thank you, Mr. Van Steen. If there are no clarification questions, I would suggest to leave all the questions at the end of all the presentation and leave now the floor to Mr. Christer Björkqvist. Just checking if there are questions. No. Okay, so we move on, and so welcome, Christer. Christer Björkqvist is the Managing Director and founder of the International User-Driven Association ETN Global. He has worked with the gas turbine industry and the research community for over 20 years. Christer, could you tell us in few words how flexible power generation could support Europe in implementing its energy scenario?
Thank you, Ugo, for that introduction, and I will try to give an overview over this. First, though, I would just very briefly like to introduce ETN to anyone that's not familiar with our activities. So ETN is a let me see if I have here the control. Yeah, so ETN is an international membership association that brings together all the stakeholders around turbine machinery. And our common vision is safe, secure, and competitive carbon neutral turbine machinery-based energy solution by 2030, implemented widely and globally by 2050. So our vision is really to become a carbon neutral technology. We have three different pillars that we are looking at: market trends, policy and legislation, and efficient, low carbon optimized operations. And finally, let's see if it's jumping too fast. Research and development. And then we have a number of working groups and projects that all addresses these different pillars. Okay, oops. So Hans here. So there are 3 points that I would like to highlight in my short presentation. First, the accelerating need for flexible power generation with a high security of supply in the energy transition, but also a carbon neutral energy system. And secondly, the flexible role and the important contributions that gas turbine technology can provide both to the carbon reduction targets and to grid stability, as I said, not only in the transition, but also as a carbon-free technology. And thirdly, the importance of cooperation, of a close cooperation among all the stakeholders to ensure development and implementation of both timely and cost-efficient system solutions. And I think it's really a vital element in meeting this target is a wide dissemination of the results of project that all have the same overall objective, in this case to increase the flexibility in a sustainable way, but each of them exploring different solutions. So Hans van Steen has already outlined the Green Deal strategy and EU's emission reduction targets. And in this strategy, I just would like to highlight the large expected increase in variable renewable generation. In this chart, you can see that the installed capacity of variable renewable energy was 21% in 2018 and expected to increase to 39 to 43, depending on forecast scenarios from World Economic Outlook. But it's not only in Europe, we can also expect such increase on a global level. And here you can see the time scale here is 2018, 2030 and 2014. And you can see a huge increase in renewable energy also on a global level. And the orange one here is Asian Pacific and green Europe, and this is North America. Next one. So here we can see that once you have all this increasing variable renewable energy, it provides, of course, a growing challenge to balance the grid. And here in this chart, you have this Californian ISO duck curve, which showcased the utility production. And here you can see how the load factor has been reduced during the time of the day, and how an increasing ramp rate has been the result in order to provide the required stability in the grid. Let's see. So the next here shows the wind generation in Spain, and here it's just showcase how wind can very quickly drop in 3 hours, and how it goes up and down. Let's move on. Oops, that was so. I think a little bit of. Should we have that? So conventional power plants can then compensate for these constant fluctuations, and it's really a key technology when it comes to balancing the grid by using dispatchable turbine machinery to ramp up and down. A key benefit of gas turbine technology is that according to the application, they can be used in a very flexible way, both for decentralized and centralized power generation. They not only provide operational flexibility, but also fuel flexibility. And it's already very, even though it is very flexible already, which enable the use of carbon neutral gases, the flexibility could still be improved, and in order to accommodate any percentage of hydrogen, to provide the utilities with opportunity to gradually increase percentage that hydrogen becomes available. Now, as the market and generation mix is changing, this technology can be further developed in a wider circular cross-vector integration between electricity and gas and heat, either on the supply side through conversion of surplus electricity to hydrogen, or at the demand side by using residual heat from power generation or industrial processes for district heating. This can serve as an additional source of energy system flexibility and security of energy supplies through power to X solutions. So without going into all the details here, I'm sure you're familiar with many of them here. I would just like to say that gas turbine technology can be an enabler in meeting this climate and energy targets, and there are several promising solutions. Some are under developments and will be presented in the following series of this webinar. But we also hope to be able to start new projects for additional promising development opportunities that can provide an increasing amount of flexibility in a sustainable way. Going to the next slide. That's too much. So this slide here just illustrates an example. Some delay here. Illustrates an example of how a flexible hydrogen society based on sector coupling could look like. I don't have time to go into the details of this, but the slides will be made available so you can have a closer look at it. It's quite interesting to see how it all can come together. Finally, I would like to highlight the importance of a close cooperation among all the stakeholders going forward, including the European Commission and policymakers. And within ETN, there exist many cooperation opportunities as we have several technical working groups where all stakeholders come together to exchange knowledge and commonly explore potential technical solutions, which we all invite you to participate if you're not already are doing so. With that, I think I'll leave it back to you, Hugo, because I think we have quite a tight schedule. So thank you.
Yes, indeed. Thank you, Christer, for this clear overview. And now, after this high-level remarks from the European Commission and ETN, which also have helped us to contextualize the issue, we would like to look more into practical needs of the industry. So from the energy sector, we have here with us Mr. Simon Balmer, the Operations Director, Gas Turbine Fleet, Uniper. He's responsible for ensuring the safe, sustainable and profitable operation of Uniper's gas turbines across Germany, Hungary, the Netherlands, Sweden and UK. With 25 years of operation in the energy industry, he has gained extensive operational and asset management experience in gas, coal and CHP assets. Mr. Balmer, could you tell us more about Uniper's strategy and what are the regulatory and policy measures needed?
Certainly, Hugo. Yeah, thank you very much, and thank you for the introduction. So first, I thought I would quickly give an overview of Uniper. Uniper is an international energy company. We have around 11,500 employees, and we operate in more than 40 countries. Our portfolio comprises power generation, global energy trading, and energy storage, as well as service provision. We have about 34 gigawatts of generating capacity, and just under 8 billion cubic meters of gas storage capacity. So in March 2020, we launched our new strategy, which included the target to have our power generation portfolio in Europe carbon neutral by 2035. We see gas as a key enabler of the energy transition, and hydrogen, both in its green and blue form, is at the center of delivering this strategy. And we already have a number of large-scale hydrogen facilities, including world firsts of demonstration plants in Falkenhagen, where we store wind energy in national grid systems through electrolysis. And we have a number of other hydrogen pipelines hydrogen projects in the pipeline, including another larger scale 35 megawatt electrolyzer in Bad Lauchstadt in Germany, work in the Humber, looking at supporting the decarbonisation of a local refinery, and including providing hydrogen for 1 million local homes, and activities in the Netherlands at the Maasvlakte site, where we're looking for local synergies with the Port of Rotterdam hydrogen hub. So next slide, please, Eliza. So here I thought I'd just explain a little bit more about our European gas turbine fleet. We have around 10 gigawatts of installed capacity, and we operate in 5 countries across Europe: UK, Germany, Hungary, Sweden, and the Netherlands. The plants we have consist of combined cycle, open cycle, and CHP applications, and most, as you see here, are based upon the turbines and technologies from GE and Siemens. In terms of the technology ranges, it goes from a H-class Siemens machine, so some of the latest and highest efficiency machines from Siemens, to vintage Rolls-Royce Olympus engines from the late 1970s, which we operate in open cycle mode in Sweden and the UK. From these plants, we provide a wide range of energy products and services to the markets. We have the high efficiency, high merit order machines such as GE GT26s that we operate in Grain and Enfield, and Siemens 4000F machines in Gonyu and CDC. So these machines run for extended periods and provide grid stabilizing services such as frequency response and reactive power, helping with the duck curve that Christer showed earlier. Mid-merit plants, such as the 9FAs at Connors Quay, they too shift regularly, providing shape around those renewable energy sources. We have the heat-driven plants in the Netherlands, where they're using the power as a byproduct to achieve the highest efficiency from fuel sources. We also have some special plants that provide power directly to the German rail system. So we have 16 2/3 frequency machines in Kirchmoser, and we equally have some interesting CHP configurations, like at Grain, which uses heat from the cooling water outflow to provide energy to regasify LNG at a local terminal. We have plants that operate on lower voltage systems to support and avoid the need for extensive grid investment and upgrades, and a number of OCGTs that provide security of supply in times of system stress with restoration power to restart from a black grid. And all of our plants in this fleet provide high levels of availability, reliability, and flexibility at maximum efficiency points with the lowest cost point. Next slide, please, Eliza. So we've talked a little about the decarbonising world. That decarbonisation journey is underway. The high reliability continues to be a priority, maintaining security of supply as we move towards increasing renewable energy sources. I lifted a small trend chart here you can see, which is from earlier this month on the 9th of October. This was a system frequency in southern Sweden. And you can see the volatility here as heavily loaded interconnector and one tripped. Here our OCGTs started successfully and helped stop that falling frequency. Another example is in the UK on the 15th of September, where we had a period of very low wind speeds across Europe and low solar energy, and the UK National Grid posted an electricity capacity market notice, which was triggered by low forecasted system margins below the threshold required. Now, ultimately, the reaction from the market to that publication led to the cancellation, but it indicates the situation we're facing with reducing conventional all-weather capacity on the system. But in parallel, we're also seeing increased operations of some of our plants from coal phase-out. We've recently announced the return to market of Urshan power plant after several years in strategic reserve due to the previous poor market conditions. But then as we look to the future, as we've talked already, there are a number of routes to decarbonise conventional power generation. Broadly cluster these into pre or post combustion, so carbon capture, use and storage, or zero carbon fuels. We see hydrogen, as I mentioned, as being a core pillar to this. And through strengthening our internal capabilities through partnership agreements with General Electric and Siemens, we're carrying out a thorough evaluation of the capability of our fleet to safely handle increasing percentages of hydrogen in that fuel supply, from the current levels up to 100%. We're looking to understand the thresholds of trigger points for the fuel mix that cause us to then significantly change, modify plant configurations, or chart to fundamentally change the threshold and technical performances. So technical questions are one area to be addressed. The other area is the regulatory framework. So in order to have hydrogen available as the fuel we need a policy and regulatory framework to provide investment certainty and to foster demand while creating a competitive environment. We see the need to act fast. We understand and agree that green hydrogen is the goal for everyone, but in the interim, blue hydrogen will be needed to ramp up the use of this low carbon fuel. We support the ambitious EU climate protection goals from the Green Deal, and we welcome the publication of the hydrogen strategy. There are still some issues to be tackled. However, virtually all of the pandemic economic reconstruction programs include a development of sustainable economies under hydrogen or other, and this should support the wider decarbonising agenda. So we see this as an ideal opportunity to take the wise step forwards together towards this decarbonised world. Thank you.
Thank you, Simon. If there are no clarification questions, then I would directly move on to the next speaker. I would leave the floor to Mr. Mauro Moretto, Vice President Technology, Ansaldo Energia. He's leading the technology development programs in Ansaldo Energia within the Research and Development Division. Before, he was based in China, holding the position of Chief Technical Officer in the newly established joint venture for gas turbine business between Ansaldo Energia and Shanghai Electric. Mr. Moretto, we have just heard the position and the needs of an end user's company, Uniper. From your perspective as a manufacturer, what is your long-term vision?
Yeah, thank you, Ugo. Can you hear me? Okay.
Yes.
Yeah, okay. Thank you, Ugo, for this introduction. I mean, thanks to the audience. We are here today, and also thanks to the interesting speech from the panelists at the moment. From what I will try, to illustrate in my speech today is to share a vision. We will go a little bit in the long term, so we try to imagine which way, as more in broad term, turbo machinery can contribute to a fully decarbonized energy system. I think the view of the manufacturer, what also I really appreciate from Mr. Van Steen is to the idea of the diversified contribution can come, from the turbo machinery industry. To me, there is not only flexibility, even if, in the past, it's kind of has been a trend to discuss and a lot has been addressed, but then we have to transition to something more, also take into consideration further elements considering the vision. So, Elisa, if you can help me to click one by one. Okay. First, we have to, go through the long term, try to imagine what can be the vision. The vision here I pictured is something we are transitioning to in order to reach a cleaner, less carbon intensive energy system driven by, if you can click twice, Elisa, driven by basically the core of the thing here is renewables deployment. In order to cope with the renewables and the variables on the power generation for that, it is there is a high need to set up a series of systems to back up and to allow the exploitation of the power utilization, but also the other use for the primary energy in order to have ultimately a much better and much higher efficiency as a whole system. So in this line, storage resources for, any kind of energy, heating, cooling, and power will be definitely have to be developed together with very high, deployment, also cogeneration systems that will bring, to the use of primary energy to a higher level. While another key word here is coupling. So industry's use of primary energy and transportation will be coupled in a better and optimized way to use energy via, complex systems and complex network leveraged by digitization. So this is the environment in which I will try in the next slide to picture the role of the turbo machinery. So Elisa, if you can help me. Okay, click one more. Okay, so we discussed and here we enter in more in we mentioned about diversification. So that is in the next elements, we will see how diversified can be the support of turbo machinery to zero carbon. We have to clarify, okay, already the gas turbines have been mentioned today, something up. Need a kind of carbon capture to be fully green or fully renewables. I think there are also other lines, I mean, to follow up in order to fit with this, zero carbon energy system, or even zero environmental footprint energy system. So, Elisa, if you can click one. Okay, I think the two vectors in which they are driven, I mean, that they will drive turbo machinery contribution are in the storage line and the grid stabilization line. We already seen, I mean, data of the renewables penetration and all the needs of the security of the supply of the power. So if you can click one more. And then we come to the green fuel. Here there is anything also including hydrogen. So I'm sure that we will have after in the panel discussion, several will be further developed, the hydrogen idea. What I see, I mean, of course, everyone at this moment, especially in the latest months and years, share the high potential for hydrogen and gas turbine utilization. What I see and what I perceive at the moment, also considering the latest issue of perspective from EU, hydrogen for power generation now is as a seen kind of a residual, I mean, elements, considering the other industries like, I mean, high energy intensive industry or transportation. So at the moment we don't see too much pushing force to take the road of the hydrogen for gas turbines. Technology are quite, I mean, at a good point, can be deployed even in a further, I mean, a higher concentration, but still, I mean, I see some difficulty to make it start. If you can click one more. Okay, I use turbo batteries as an element in which turbo machinery can contribute in this way as a concept, as a complete battery. So backing up similar to what can be done with hydrogen, the variance and the volatility of the renewable resources. Turbo batteries is any application in which an energy carrier is pumped to reach an energy concentrated state and then processed to release its energy. This, I think, can be done with quite interesting level of round-trip efficiency. There are several competitors. I think the storage area and the storage, it's a technology race. It started several years ago, it's keep on going, and it's very interesting to see how it develops. I'm convinced that there is a nice space, a nice potential for turbo machinery to have a great contribution in this. If you can click more, okay, here we are more in the flexibility in the generation resources, providing dispatchability in order to back up the renewables variability. I think there is a space here to exploit the potential still in the green area in order to have a zero environmental impact, to new thermal cycles. Pretty much in the oxy-fuel combustion cycles, I think there is a nice potential to arrive to a good turbo machinery power generation resource, which is ultimately green. Of course, we have to deal whenever, I mean, we may end up to use some fossil fuels to treat properly the carbon, but there also there are all the promising technology lines to utilize the carbon as in the as a nanostructures industry. Synchronous inertia, it's another element in which turbomachinery can contribute as a fundamental impact to stabilize the grid. So we always see whenever we come to, power system with more renewables, we need a way and a clear way to back up and have a properly addressed the lack of the spinning reserve due to the fact that more renewables are entering this. Another click for hybridization. Speaking of flexibility, I see here nice potential for hybridization of different resources, in which, of course, turbomachinery play a stronger role. And hybridization, it's a kind of combination of renewables and storage resources and even new green cycle resources to properly, contribute to the grid in a kind of autonomous mode in which there is it is realized a kind of auto backup. So in which in any condition this hybrid cell can contribute to the security of the supply of the power. Last click is to emphasize that the other phase of the transition, the energy transition, there is a high potential, we have to take care, there is a possibility to repurpose existing fuel assets in something very much in line to the decarbonization area. So I see a very much promising space also here in order to complete the transition as the long-term vision we have seen. With this, I concluded. Thank you very much.
Thank you, Mr. Moretto, for this really clear exposition. So I would finally thank all the speakers for their clear and concise remarks. I see now there are some questions already in the chat box. So I would first pick the first one. And I think this question goes a bit to all the speakers. I would start from Mr. Hans-Mann Steen from the European Commission. And this is the question. The hydrogen economy has been announced for the past 20 years. No major breakthrough has been achieved in long-term storage, and power to hydrogen is still quite expensive. How will hydrogen help us to bridge the gap in storage? I think power to hydrogen, but also power to X technologies.
Do you want me to come in on that one to begin with?
Yes, please.
Okay. Thank you very much. First of all, thank you to all the speakers. I think very, very interesting presentations. And to me, really, it showed how relevant the whole topic of energy system integration really is. Because I heard these three presentations as largely showing practical examples of how we need to have a much more integrated approach towards the future energy system. So I thought that was very, very useful. Now, on the question specifically on hydrogen now, yes, we, of course, from the Commission are very well aware of the fact that many people have talked about hydrogen for quite some time and seen it as the solution to all our worries. and it hasn't happened yet. So the question is, what has changed now? And I think something that has changed now is that we now have a clearly, commonly agreed objective of much, much deeper decarbonization. And we know that there are certain areas of the economy that will be very hard to decarbonize with the technologies that we have today, especially electricity, but also other things. Biomass is, of course, important, but it comes with other challenges, as many of you will also know. So we think that hydrogen is actually a good option to decarbonize certain hard-to-abate sectors. It is not the silver bullet. And I think if that has been created by that impression by the Commission's strategy on hydrogen, I think that is unfortunate. Hydrogen is one element of energy system integration, an important element. And on the specific question of whether we could imagine also hydrogen going into electricity generation in large scale, I would say probably not. We see it more for certain types of industry, certain types of transport, where we don't see other alternatives. For electricity, we have a lot of alternatives out there. Not to say that it will not happen, but I think the priority for hydrogen are areas where perhaps alternatives are not yet there as we see it today. Let me perhaps leave it there, but also interested to hear views from other of the speakers.
Yes, thank you, Mr. Van Steen. Yes, indeed, it would be interesting to hear the view from Simon, from as a utility point of view.
Yeah, happy to give a response. Thank you, Hugo, and thank you, Hans. I smiled when I saw the question rotate past on the chat with the comment around the time that we've foreseen hydrogen, and I think back to Jules Verne. I think was the sort of founder of the visionary of hydrogen as a potential fuel source to provide an inexhaustible source of heat and light. So I think we've had hydrogen on our agenda for quite some time. I think from a comment on the application of hydrogen in gas turbines, I think with the modelling and the future scenarios that we can see and a number of the different perspectives that are presented on that, there will be a need for that flexible all-weather power generation. That seems to be the requirement, at least out to 2040 and maybe beyond. And I think this is where the flexibility, the reliability, and the general availability that you can get from established technologies plays a part. I think we need them. I think what is not needed is the current carbon emissions from them, and that's where I see hydrogen as one of and agreeing with Hans, it's not the silver bullet, it's one of the routes that you would have to ensure you have that capacity, that flexibility, but you have it when you need it, as I showed in my brief discussion earlier. I think the context, the world in which we face and find ourselves in is very different, and I think the alignment and the energy that is going into a decarbonising agenda is significant, and I think that's probably linking to the question. That's probably what's different today than maybe in the past.
Thank you, Simon. I would then like to hear the view of the manufacturers, of course, Mr. Moretto.
Yes, thank you. But yes, the discussion of hydrogen, it's kind of intriguing. I think we are in this moment in a kind of dilemma in which we have from one part a great solution to start and having make it real, some reaching some less carbon intensive power production. But on the other side we have a fantastic benchmark of natural gas what that is, I mean, competing with hydrogen, and I believe as soon as it will stay, I mean, below, I mean, the 10 euro per megawatt hour, I mean, it's going to be tough, I mean, to be beaten, even imagine, I mean, large quantity of hours having overproduction from renewables. So in a way that the production of hydrogen can be economical effective. So in this dilemma is not there is not yet a clear way. So the manufacturer strategy is we are trying to diversify from one line. We point, I mean, what is the idea of a 100% in order to, in the gas turbines, to make available and enable technology and gas turbine to use 100%, but we know this, the path to have such quantities of hydrogen available for power generation is very, very long. So at the moment we address this situation in two lines. One, have as much as possible technology to retrofit existing plants in order to, whatever any quantity of hydrogen is ready to have available for, I mean, revamping a kind of existing assets. And also second line to arrive to technology or to new units line that can anyway ready since now to burn some portion of hydrogen mixed with natural gas. But still we have, like I was saying before, the perception that, I mean, having this benchmark and also having other, if not the silver bullet, having other kind of lines to follow for the energy system, it will take time to grow.
Thank you, Mr. Moretto. I would then hear the opinion from Christer Björkqvist, since ETN Global is operating both at European and global level. Could you tell us more also what is how hydrogen is seen at international level, also related to this question?
Well, just to go back a little bit to that question that was asked before, I think it's important to say that yes, there has been discussions about hydrogen for a long time, but not in this focused way by both the government and all the different stakeholders. So I think this is a very good, clear strategy that is being developed, which will make it happen. I think it's also important to remember that when we talk about balancing issues, we're not just talking about short-term balancing. As we have more and more renewables in the grid, we are talking about much longer period across several days, weeks, and seasons, which present a much more significant challenge to have the required large amount of energy available. And that's where I think that maybe centralized also hydrogen use of gas turbines for hydrogen could be of interest in the order of maybe up to 100 megawatt and that size. When it comes to the global situation, I think that it's important to highlight that it's not only in Europe, as I also showed in one of the slides, that we need this flexibility, but also in other parts. And I saw a study in the IEA where they said that in India's power system in 2040 that you will need 6 times more flexibility than today. In China's 3 times more. And so these are in developing countries, there's a huge need for this flexibility. But also in the United States, they estimate 2.5 times more flexibility needed by 2040. So I think that there are definitely opportunities for for hydrogen, both in for decentralized and centralized generation. I think it's important that we cooperate with different countries, Japan, US, to exchange information on demonstration projects, etc., to drive down the cost. We need to have this global, let's say, network of exchanging information from those demonstration sites. And within ETN we are cooperating. We have started cooperating with the GTI in US, who is also very much focused on this. So I think that there are definitely opportunities that will come, and the cost will come down also when we are cooperating more and exchanging information.
Okay, thank you. Thank you for your valuable inputs. I think we are running out of time, so I would just really quickly ask to each presenter to really state what is the takeaway from this session for them, and then we have other question in the chat box, but unfortunately we don't have enough time, so we will follow up on this after the webinar. So yeah, I would just give like really few seconds to each speaker, starting from Mr. Van Steen.
Thank you very much, Ugo. Really, very, very briefly, I think my takeaway from this is that there is a lot happening. There's a lot of potential. There's a lot of technological opportunities out there in terms of creating the flexibility that we need. As I said in my intervention, the flexibility can come from so many different elements of the energy system, both on the supply side and the demand side, and we really need all of them. And I think it's good to see that the flexibility is equally present in terms of the turbo machinery, and from the Commission side we will continue to support that whenever we can, both in the policy on the policy side of things, but also on the research and innovation side. So thank you very much for organizing this. It's been a pleasure. Thank you.
Thank you, Mr. Van Steen. Simon, would you?
Yeah, certainly. So from my side, thank you firstly for the facilitation, the opportunity, and for everyone who joined. I find we're at a really exciting opportunity. The question that's never asked is why. It's always how, and it's always a question of the challenge around how do we now make this happen. And within Uniper, we've set 2035 as our target for the European portfolio to be net zero carbon. And we'll be deploying all of our efforts, all of our experiences, and working collaboratively with all the stakeholders and partners on this journey to achieve that target.
Thank you, Simon. I leave the floor to Mauro.
Yes, thank you. Thank you for an interesting discussion today. I'm quite in the line with Simon. To me, still we have to work more collectively. In order to find the right way as a sector, the right way to get out, because I have a strong feeling we are losing opportunity to start and to do something since, today or tomorrow. So just we have to find a way how to, cooperate and put operators and technology providers all together to follow a line and start having work. So this is my takeaway, and I think is more and more important to do it.
Thank you. And also I would like to hear from Krista.
Well, I think one important thing is to bring together the user community to have a more coordinated view of what is really needed and required, so we can provide this to the R&D community as well as the manufacturers and suppliers and so on. And that's something that we are working on within ETN to try to do, to really create the needs and requirements going forward. We have many promising development opportunities, and we need to define, they say, the most promising, and to follow up on these paths together. Thank you.
Thank you. So thanks everyone, all the speakers. It has been really a pleasure for us to have you with us for the for the first episode. I just put in the chat the link to register for the second episode of the webinar series, which will take place on the 3rd of November, and will focus on the Flex and Confu project. Again, thanks everyone, and yeah, see you to the second episode.
Thank you.
Thank you.